All right, good morning, everyone. I will be talking about what I have done so far and what are my thoughts and why did I did that. So it will be like a video to summarize everything. So maybe I will forget in the future, or there is something I needed to highlight it now so I don't forget it and give you a basic idea. So to start with, the circuit is pretty simple. We just have the microcontroller, which is an ESP8266. Why I have chosen this controller is because like it does the job. It have a Wi-Fi module built in. Is it the best option? Not really. Okay, but it can do the job. What's the better option is like an ESP32. Why ESP32 is better? Because it have dual cores, and it's the architecture of the ESP32 is a little bit of different. So when coding in ESP32, it will be like a little bit easier than ESP82.6, but it doesn't really matter. But that's something to keep in mind. Then we have a PIR sensor, which is like an infrared sensor that doesn't only depends on the infrared, it depends also the change of heat waves. So if you have an idea about sensors, there is no such thing as a motion sensor exactly. There are multiple ways to detect if there is a motion. So based on my research, I have seen the ultrasonic, the IR sonics, the microwave sensors. Based on our use case, I thought that PIR sensor would be the best, and I don't think that's it will cause much trouble. There are some problems with the PR sensor, and I will explain how I have dealt with them. And yes, so also we have a relay. Why do we have a relay? And this is like a 5 volt, and this is 3 volt or so. Uh, the relay is just to have when I code, I want to have the intention that this could be upgraded down the line if we want to like to get a bigger PIR sensor and we need a voltage supply or something like that. It's designed already to handle the swap, and if we don't see the need to switch to a better PIR sensor, so it will work fine. The LED will just be a sample for the output to disseminate the idea. Okay, so I was going to mention what are the problem with the PI sensors. So the problem is that when you start the sensor, it will have some error. Like, so when you start it, it could have false reading. So how I have dealt with that is just through the documentation or the datasheet of the sensor. They have like it's it's so the best thing to do is like have a calibration period, which I have like put for 30 seconds, so it won't read until it is fully calibrated. And also I have added like if the detection is in a very small time and just maybe a false true, don't count it. And the main thing is the read state, which is like a boolean variable that will tell you if we need to get the readings or not. This variable will help us then see how we can integrate it with the cloud easily. So run the let me run the code. So this is also a good time to introduce this. This is Platform IO. It's a platform for microcontrollers and embedded system. It offers much advanced facilities and a much suitable environment than Arduino IDE to develop. The, that's why I prefer it over Arduino IDE, and it's also native C++. So it's better in developing also. Okay, okay, let's see. Let's wait. Okay, while we are waiting, so what will happen to be what will happen is we will have the IT core, which is a service that is in AWS, and we will be sending like MQTT messages, which is a standard protocol for communicating with device. We could do this later when we want to send data from the Raspberry Pi to the microcontroller, we can establish an MQTT server and send the data throughly. But I'm considering and I'm researching about IoT greenhouse, which from the basic thing that I have derived until now, it will like let you be able to communicate between the Raspberry Pi and the microcontroller locally, and it will be يعني, the easiest thing, or I'm not sure, so I'm still researching about that. Okay, so as you see, I'm connected to the internet. Then I'm connecting to the IT core. So how are we able to establish this? Basically, we have like the endpoints, the certificates that we need, the the certificate and the private key, and then you will use SSL to an access or get to the IoT core, and and we need to use time to authenticate that's really happening in the real time. So the first reading is, as you can see, I put motion detected at 100 seconds, just so you know when you have detected it. Then oh, the motion ended after 1 second. Okay, now if I have put my hand, you can see there is no motion detection. Why is this happening? Why there is no motion? Because I've programmed it in a way that only the first motion detection will be detected. Then if you want to be it detected, you can send like a payload using MQTT to make it on like one. Okay, now the monitoring is on, still didn't take a sensor. Okay, it will read one time and then it will see how long the motion will be detected. Okay, so it's like 2 seconds here, it depends, but now, okay, but now it doesn't really count it, no matter how I try. So that's what I have done. Also, we can subscribe to a topic, like, okay, let, okay, if I subscribe here, okay, I'm not sure. Yes, okay. Yeah. We can see the read state is false now, and we can from this topic we can derive this information to the Raspberry Pi easily since it's already in the cloud and it's on JSON format. So it will be easy. That's what I have done so far. What is next is researching how Simona, how we will send, what is the best way to send the message to the Raspberry Pi or Lex to be exact. Okay, is it gonna be like directly through APIs? Is it gonna be like through Greenhouse or something, or just uh, establish MQTT server between the two and let them send information to each other? That's what I'll be looking through the next sprint. Uh, I am like ahead of the spring, so I will be adding new tasks because this task was supposed to be in the next sprint, but it was for me it was much easier uh, to answer the question of the current sprint by doing this. Okay, and thank you for listening. Sorry for taking like 9 minutes out of your time. Bye.